Welcome back. Over the last few videos, we looked at sprinkler systems and how they work and how they're monitored by the fire alarm system. The type of sprinkler system we looked at was called a wet system, and what that meant was the sprinkler pipes were always filled with water, and that water was sitting right at each one of the sprinkler heads, waiting for it to burst from a fire, and it would extinguish the fire. Well, that works great in most applications, but pretty often the sprinkler pipes have to travel through, or in some cases, they're actually protecting an area that commonly drops below 32 degrees Fahrenheit, which is the freezing point of water. So if you have any portion of your pipe passing through that environment, so maybe the pipe network is run in an attic, an unheated attic, or maybe it's protecting a freezer or a loading dock or whatever, you can't leave it filled with water because the pipes are going to freeze. The water's going to expand when it freezes, and it's going to burst the pipes, and you're going to have a big mess on your hands. So the solution for that, or the solution to that, is what's called a dry system. So I'm gonna explain how a dry system works, and this frame looks a lot like one that we looked at the other day, but there's a couple small additions. So we still have our city water incoming on the bottom here. It's going to come in and branch off to domestic water on one side, and the sprinkler water is going to go the other way. So we remember our backflow preventer, and that backflow preventer, like we talked about the other day, allows water to flow this way, right? But because this hinge would pop right up, but it doesn't allow water to flow back, hence the name backflow preventer. So again, it's a little bit more complex than that, but that's basically it. And each one of these valves would shut off the water at any point, and they're going to have valve tampers on it. We talked about that already. But there's a couple new things here. We have this dry valve up here, and we have an air compressor. So if this is a dry system, the way this would work is, well, let's fill the system up for right now. We're going to assume that this new valve this new valve I put in right here is going to be closed for right now. So let's fill the system up. Water is going to go up to this valve, but it's not going to go past it. So this dry valve that I drew, what this is it's this little yellow, this little yellow line is called a clapper. This thing would be closed down, and there's this little hinge on the end of it. And what that does is it'll kind of hook and seal this valve shut, but it's not very strong at all. And I'll explain that in a second. So let's assume that we shut this right now. Once this thing is shut, we would seal our little hatch that lets us access this. But anyway, this thing's going to shut, and then we're going to fill this pipe with compressed air. So we have an air compressor up here. And this thing's going to put air in this system and pressurize it. So this pressurized air is going to be pushing down on this clapper, and that's what's going to keep it shut. So maybe I should draw that shut right now. Give me a second. The unique thing about the dry valves is if you look at the openings on them, if you look at the opening on the water side, so I'm going to draw this thing shut right now. This valve is shut. But if you look at the opening where the water would be allowed to, well, let's say we pressurize this real quick. Let's pressurize the system, and now we can fill up the system to this clapper because there's pressure up here. So we can we'd open this valve up basically, and the water would get to right here. And the reason it's not strong enough to push this clapper up right now is because of all this compressed air. But the interesting thing is, it doesn't. Let's say I don't know what the city pressure typically is. Let's say it's anywhere from I don't know. Let's say 60 to 100 psi. I know that 60 is fairly common. I don't know what the upper range of it is. In more complex systems, you start getting fire pumps, and the pressure can get pretty high. But let's say it goes from 60 to 100 psi. The air pressure, depending on the size of the valve, it can be up to 5 times smaller than the water pressure. And the reason is the surface area of this clapper. So you see how it's nice and wide along the edges of this dry valve. Well, there's going to be all of this surface area of compressed air pushing down on a very small surface area of water, right? So hopefully that makes some sense. So theoretically, if we had 100 psi even, If that were true, we could have 1/5 as much compressed air. Then you could have 20 pounds of 20 pounds per square inch of air pressure. But typically, what you see is you typically see the air pressure at around 40 psi. That's pretty common. I think that's what the um, low air pressure switches, which we'll talk about in a little bit here, that's what they typically come preset at. So let's say 40 psi is typically what you'll see. This pen's hard to write with, so I apologize. But that's typically what you see. So this pipe up here would be compressed um, at 40 psi. So you have maybe 60 to 100 pounds of water, and 40 psi is all that's really holding this back. So what would happen is, if the sprinkler heads are still going to work the same way, if one of these got too hot, the chemical inside the glass tube would expand and burst that glass tube, and then all this air would leak out. Right, so the air is going to leak out pretty quickly, and then once this loses pressure, once the system loses pressure, the water is going to push open this clapper, because, like I said, the little latch here is not strong enough to hold back all this water pressure, and then the system's going to fill up with water. And once that happens, if one of these heads is already burst, it's going to shoot out whichever head is burst. And in my drawing, I guess I'm going to flood my compressor. So let's look at, hopefully that makes sense. Let's look at how it's tied into the fire alarm system. What do we have to monitor now? Because it's a little bit different. Well, we're still going to have to monitor all the valves like we did before. We don't have to monitor this domestic valve, right? Because that's for the same reasons we didn't before. If this is shutting off the water that you'd use in your sink, so you're going to be using that every day, and you're going to know if there's a problem with that. You're going to know if somebody shut that off. But because you don't use your sprinkler system every day, you might not know if you shut any of this off. So each one of these valves along the way, every single one of them is going to have a valve tamper. So I didn't draw that in, but assume they're there. So you're going to have a valve tamper here. You're going to have a valve tamper here. Our new valve is going to have to be supervised as well. And now we have two new things on here. So now we have this, what I call a water pressure switch right here, and an air pressure switch up here. So first things first, if in a normal situation, when our dry system was working properly, this clapper would be closed and this system would be pressurized with air, right? So we're going to have, let's say, just to make it simple, let's say we have 40 psi of air. Well, let's say our compressor quits on us. It no longer is working, right? Over time, this pipe system's not going to be perfect. There's going to be very minor leaks. So, from time to time, the compressor normally kicks on and just boosts that pressure up. There's a regulator that's set at 40 psi, and it's going to, pump air into here to make sure that everything's working okay. Well, let's say that the compressor fails, and over time we start to lose pressure. Well, hopefully our system's fairly well sealed, so it's going to take a while, but eventually we're going to drop below a certain point, right? And we'd like to know that. So they have these air pressure monitors on the air side of it. So again, in a normal situation, there'd be no water in this pipe, so this is an air pressure monitor. And by code, it's required to monitor both the high monitor on the high side and the low side. So you would calibrate it based on what you calculate your needs. Let's just say it's 40 psi. So there'd be two sides to this switch. There'd be a high side and a low side. So we got our high side. We'll just leave it at H so you don't have to watch me write. And a low side. And the high is going to be plus 10 psi. And the low is going to be minus 10 psi. So if we're set at 40, our high is going to be at 50 psi, our low is going to be at 30 psi. And we'll wire that into the fire alarm panel, and it's going to be a set of contacts just like everything else has been so far in fire alarm, right? It's going to be, they're going to have a common, a normally open, and a normally closed. And we'll explain that in a little bit. And you'll monitor both sides of those. Now, I've been doing this for about 5 years, a little over 5 years, and I could think of one instance where I've seen them actually monitor the high side. They almost always just monitor the low air pressure, and that's the most common thing that you want to know. If your air compressor, I can't say that word, if your air compressor quits, you're gonna lose pressure, and you're gonna want to know before the panel goes into alarm, which I'll explain in a second. You're gonna want to know you're losing pressure, so you can come, have somebody look at your compressor and fix it, whatever. Or if you have a leak, fix the leak. But let's say your regulator quit. The regulator is what limits how much air gets put into the system. So it's gonna monitor the air with its own pressure switch, and then it's gonna shut off the compressor. Well, if the regulator fails and it's constantly pushing air into here, let's say this system gets to 200 psi. Well, on the one hand, you're going to be pressuring all the joints in your system, all the unions and everything else like that. And also, if there is a fire and one of these sprinkler heads burst, it's going to take that much longer for all the air to drain out, and then the water, to subsequently come out as well and put the fire out. So you're going to have, an even higher lag time before your water is actually putting out your fire. So that's why you want to monitor both the high and the low. And shortly, I'll explain how you do that. Probably in the next video, looking at the clock. The next thing is a water pressure switch, and you can see that's on the other side of the clapper. And if you look, I think I'm actually going to zoom in here, because if you look at where this is on where this pipe comes out. So you have a pressure switch that works basically the same way, and it's going to have two sets of contacts as well. But if you look at where this is, if this yellow clapper were closed, it would also be sealing off the little area here where this pipe is located. So in a normal instance, there'd be no water in here. It would be sealed, but as soon as this thing opened, now the water's going to come through here, it's going to get into this pipe, and it's going to hit this switch. And this switch acts like a water flow switch does on a wet system. You might be thinking, well, why couldn't you just put a water flow switch somewhere on this pipe? And the reason is, once the system actually trips, there's so much pressure from this burst of water that it could actually break the paddle on that water flow switch, and it would be useless. So it is required that there's a pressure switch monitoring these dry systems, and they're really effective. There's usually a little test valve where there's a whole, these systems are a little more complicated than I'm drawing. There's all these other pipes that do, various things, but since we're worried about fire alarm systems, we're not going to get into that. But there'd be a little way to test it where you open up, and as soon as the water hits that pressure switch, it's going to trip right away. So it's pretty effective. That's basically all I want to get into on this video. In the next video, we're going to look at how we actually wire these up to the fire alarm panel. But the last thing I want to mention is when you close, if you were to open one of these things up once, let's say you shut off the valve, there's not really much water in here, so you should be okay. There's all these big bolts that you take off. There is going to be some water in this system, because once you close these clappers, you usually fill water in that, not a lot, just maybe even a couple cups or maybe a gallon or so, just to kind of help with the seal. So you would have some water right above this line, and the air is going to be all pushing down on that. But I just mentioned that. I don't know, I guess just as some background information, but also just so if you ever, you think you know what's going on, you take one of these off, there is going to be some water in here, so be ready for it. But that's where I want to stop here. I already went longer than I wanted to. And in the next video, we'll look at how we wire these up to the fire alarm panel. I'll see you in the next video.